Hi, I am a tutor in Uplatz. Today we are going to discuss about MATLAB Coding Guidelines Part 4. Minimize use of global constant. It can be convenient to use a constant that is defined once and used in multiple locations. This effect can be achieved by declaring the constant as global, but there is a price to pay. You must find the code that defines a constant before you can use it. Because the location of this code may not be obvious, you can also inadvertently and inconsistently define the constant in more than one location. MATLAB does not have two constants. They are all really variables that are or should be resistant to change. These are several strategies for working with constants that are used in more than one code module. The recommended practice is to define constants that would be used in one or more than one module as functions. This reduces the likelihood of unintentional redefinition. Also, the constant name can be easily used in an expression. Using a function to define a constant is a common MATLAB practice. Use the standard convention for naming this function. The function definition would look like function value 2 pi, value is equal to 2 star pi, and the single usage will be circumference is equal to 2 pi star radius. If the execution speed is an issue, then you can use an anonymous function circumference at 2 pi star radius, or make a local copy 2 pi constant equal to 2 pi circumference or 2 pi constant star radius. With the easier to scan and type correctly is empty A. The expression A equal to 0 or A equal to null and are not useful because they are always written null. Although it works, avoid checking whether a string variable is empty by comparing its length to 0. The purpose of this statement is not clear as simple. Use of is empty, avoid length A equal to 0. The use full file. The full file function generates a path to a file that is system independent and flexible in dealing with embedded file separators. Replace this file, this / directory / name with a more portable and easier to read this file, full file, this directory, file name. Compared with numbers for speed, computing with index numbers can be much faster than working with directory with character strings. In particular, working with date numbers is usually faster than working with the date strings. If you write clearly with good variable naming, this usage need not reduce readability. Consider using characters arrays for speed. The use of cell arrays for characters strings can be easier to read, but working with character arrays can be faster. Try to limit this usage to cases that do not significantly reduce readability. Consider using unique, take advantage of duplicate values in a string variable. Use the 3 output argument feature of unique list, the list index, unique list. Using this option output indices in subsequent computation can occur faster and more elegant than decomputing equivalent indexes in additional statements. Use structure for association data. Structure provide an easy way to keep associated data together. For example, you may have a set of gross domestic product data by country and year. Instead of using a variable GDP, country, and year, you will use the structured GDP with file names, value, country, and year. Using a structure can help keep the sizes of the field consistent and also support writing functions with a fewer input arguments. Structure provide an easy way to keep related data together. For example, the results of an experiment could be kept in a structure so that you do not have to keep track of each relevant variable or parameter. This is particularly convenient if the results of several similar experiments are stored in files in a single directory. Flight 10 02 airspeed 1 as speed unit in PH, altitude 1,000 double altitude unit feet. Time step is 1, time step unit is equal to second. Equipment A7 pilot joint plan description practice, event time 20 to 1 double, event log 20 to 1 12. Organize a structure based on how it will be accessed. A structure is likely to be read more often than written, so organizing it for simple read access will produce cleaner code overall. Consider a structure with data for multiple flights. Its most frequent access is one flight at a time, then the structure has flight, in flights, and without airspeed. Examples of most frequent access is all flights one flight at a time, then use a structure organized as flight.airspeed and flights and samples. Put structure fields in a helpful order. MATLAB does not consider field order for functions like is equal, but using alphabetical ordering can make it easier for the reader to find a field in a structure. This way, you can use the order field function to provide a structure with fields in an alphabetical order. Some users prefer to order the data fields first, followed by the metadata fields in the order of the field, which is not about the format as be refused. It is be a factor in readability. Be careful with field names. When you set the value of a structure field, MATLAB replaces the existing value if the field already exists or creates a new field if it does not. This can lead to unexpected results if the field names are not consistent. For example, in the structure as a field activist that shows CNN that you intend to update, but you type activist source name equal to Bloomberg. The structure will now have two fields, a less error-prone version will be if is field acme source name, acme source name Bloomberg, else error field set name, use a valid field name. End. This code snippet could also be generalized and written as a function for safer and more convenient use. Another way to avoid this type of problem is to use an object rather than a structure. One of the benefits of object is reference to unintentional field creation. Consider using cell arrays for strings. Cell arrays of characters, strings can be more readable than character arrays. Particularly the strings and lengths, using cell arrays and count spaces to write greetings I world, or use the function greeting gs is called char I world. However, in both cases, the indexing would be in the form greeting I line, and with a cell array you can write greetings I colon word and index with the more direct greeting I line. It can be easy to look out for cells within the cells. It can be easy to write greetings. Curly bracket 1 is what I, when the design statement is greeting curly bracket 1, I, or getting curly bracket 1 is what I. Where complicated syntax for correct access of the character string. Consider use cell arrays for ranked arrays. Most array in MATLAB must have uniform numbers of rows and columns. If the elements in your data set do not have this rectangular shape, then you have two choices. You can use a padded array or a cell array. If the data have a natural element such as uniformly spaced samples with some missing value, then use a non-padded array. If the data do not have natural alignment, then use a padded array may be misleading. In this case, use a cell array. Using a cell array will typically be slower than a non-padded array, but you can use cell array functions for better performance. Write short expressions to enhance readability. Try to use less than 7 elements in an expression. Look for opportunities to use explanatory intermediate variables and an expression like is nan this value and this value greater than or equal to initial threshold, and now tilde is member value array should be replaced by something like value is present is nan this value is valid this value greater than or equal to initial threshold, value is new is tilde is member this value array, value present and then value is valid and then value is new. The later version makes it easier to visually parse the overall expression into meaningful sub-expressions and to see the sub-expressions are correct. Put numbers before the multiplication operator. When a variable is multiplied by an explicit number, put the number before the operator and the variable name after, because you should minimize the use of numbers within the body of the code. This rule applies mostly when defining a variable that replaces a little number. Replace 2 pi is equal to pi star 2 pi is equal to star pi. The reverse order is appropriate when the number is in a numerator of a fraction. fudge factor big start 2 by 3. Make the denominator clear. The scalar expression a slash b star c and a star c slash b produce the same result, but the second form can be understood more quickly. And similarly, a slash b star c slash b is not clear as a star c slash b star d. Use parentheses. In the MATLAB language has documented rules for operator precision, but no one wants to remember the details. If there might be any doubt, then use parentheses to clarify the expression. They are particularly helpful for extended logical expression. The expression A equal to B and C is evaluated as A equal to B and C, although A equal to B within brackets B and C may be the intent. The expression A star B slash C star D is evaluated as A star B slash D star D. The intent may have been A star B slash C star B. If not, it would be better to write A star B star D slash C. Use a clear form for relation expression. Relation expressions, including negations, can be difficult to understand. Strive to use positive expression. You can be able to write a positive form by using the complementary operator. Replace tilde is sample less than sample max samples with I sample is greater than equal to max samples. Use and are by default for scalar operand. Use and are by default, and put expression in the best order for short circuiting to the avoid errors, warnings, or unnecessary computation. Use exit A and A greater than 0 or is empty A and A greater than 0. When the operands are not scalars, we must use ampersand or instead of short circuiting operators. Break short statements. Statements are easier to read when they are short. In particular, try to avoid unnecessary line wraps by introducing intermediate variables and short expressions. Statements avoid use of eval when possible. Statements that involve eval tend to be ordered to write correctly, more difficult to read and slow to execute than alternative. Use of eval does not support thorough checking of by intent. Statements that use eval can usually be improved by changing from commands to functions or by using dynamic field references for structures with set field and get field. Avoid use of eval when possible. Reduce use of eval by using the function form rather than the command form. The command form is more limited than the function form in working with arguments. The command form often requires a more cryptic statement than the function form. Replace eval load August integer to string index.mat with load August integer to string index.mat, and also minimize the use of eval in. It should be used to secretly pass values into function. Use arguments instead. Initialize loop variables immediately before the loop. Initializing or pre-allocating the variables that are updated in a loop improves loop speed and helps prevent bogus values if the loop does not execute for all deciding indices. Placing the initialization just before the loop makes it easier to see that the variables are initialized. This practice also makes it easier to copy the relevant code for use elsewhere. If a loop is not double, then assign a step when you initialize it. Result nan in index, 1 for index, 1 is to an index, result index, 2 index n. Initialize, use nan or false rather than zeros. Now that nan is available as a function, use it. Because zeros can be valid, result of many computation. Incomplete element computation is easier to detect when the array is initialized to nan. Aloha nan enters n column. If the variable is boolean, then initialize it using false. This practice prevents subsequent MATLAB code from interpreting 0 as an invalid index. Results is valid, false, enters and columns. Do not change the loop index variable inside the loop. MATLAB captures the loop index variable for use in executing the loop. You can change the variable with the same name inside the loop, but the result may not be what you expect. In any case, changing the apparent value of the loop will confuse the reader. Minimize the use of breaks in the loops. This keyword is often unnecessary and should only be used if the code proves to have a higher readability than a structured alternative and it is well tested. A loop containing break will have more one output path. This can be confusing in nested loops with break statement. It is not always obvious with statement to be executed. Next, replace FID, fopen, FFT, dot M, read yes equal to blank. Minimize the use of break loops while not if you FID line FID is empty, then break and S is equal to structure events S comma line with FID is equal to FTR is blank, text line is equal to star, while not FID and then is empty, text line is get L FID, S is equal to STR cat yes comma text line end. Minimize loop or continue in loops. Minimize the use because this keyword is often unnecessary and should only be used if the code proves to have higher readability than a structured alternative. The following example reads a text file of unknown length, FID open magic.m or count n, while not FID line get L FID if is empty line and string compare line count plus 1. This code can be easily written without until by changing the sense of the statement if statement of the if statement expression. FID is open magic or count while F not FID text line FID count update count text line and F plus FID together the function count update count text line is if E is empty text line and then is string comparison text line. Yeah. This version also renames the variable line to avoid confusion with the function of the same name. Avoid unnecessary computation, save execution time, and make decoding easier by avoiding repeated computation that are not needed. Replace for I rows 1 and rows, J 1 and columns, term I rows, J columns, sum of X rows, I colon sum X colon J column and N. With the clear and faster for I rows 1 and rows, or sum X row I colon for J column 1 and column term I rows J column is equal to row sum plus sum X colon J column and N. Be careful of infinite while loops. Code blocks using while loop can loop indefinitely if the exit condition is not written well. For example, an equality test involving coding by number may never pass. This loop not terminate. A is equal to 30, B is equal to 0.1, while A not equal to 0, A is equal to A minus B. And this when does A is equal to 30, B is equal to 0.1, while A greater than or equal to 0, A is equal to A minus B. And it is easy to write the code like count is equal to 1, value is equal to 3, decrement is equal to 1, while value greater than 0, value is equal to value minus decrement, count is equal to count plus 1, end. Be careful of count errors in while loops. This produces a count value of 4 because the desired value is powered by 3. The code should be count is equal to 0, value is equal to 3, decrement is equal to 1. When value greater than 0, value is equal to value minus decrement, count is count plus 1, end. Avoid complicated conditional expression. Introduce intermediate logical variables to reduce complexity by assigning logical variables to expressions. The program gets automatic documentation. The construction will be easier to read and debug. Replace if value greater than or equal to low limit and value less than or equal to high limit and is not is member value and non-values. N with is valid value greater than low limit and then value less than high limit. Is new is not is member value and no values. If is valid and is new is the right way of writing. In general, include an else statement with if. The else block provides an opportunity to deal with an alternative or unexpected value. Replace if I state less than or equal to 0 and display state I state and with in state is equal to 50. If I state less than or equal to n state, display state I state, else error keep I state smaller than n state plus 1, and put the normal branch in the if pod. Put the normal branch of any if pod if statement first, unless placing the special case first makes the construct more easily understandable. This practice improves readability by preventing lengthy special cases from obscuring the normal path of execution. For example, code that reads a file might be clearer if the code block that reads the file is placed before the code block that is executed if the file is not successfully opened. FID open file name. If FID greater than or equal to 0, else enter. You can avoid unnecessary if constraint. You can open the replace codes such as if expression values equal to else values for codes and values equal to expression. Use a practical order for else conditions, and selection constraint has many choices. Readability is improved if the choices are in some types of order. Typical ordering includes numerical order as in 0, 1, 2, 3, or article order for character strings. Avoid unnecessary a selection construct with apparent but unnecessary choices can confuse the reader. You can often clarify the construct by replacing literal numbers with named values. Replace if hours less than 40, pay equal to regular hours. Else if hours greater than 0, pay is equal to overtime hours. Else if hours equal to 0, pay regular hours. Else error bad condition. With normal hours is equal to 40, if hours less than or equal to normal hours, pay regular hours, else pay overtime. Avoid unnecessary levels of nesting in the structures. Code within if such contents can become messy if the cases are not well designed or if the additional conditions are added to the original version. Any organization can improve readability. Remove all of duplicated codes can also make it easier to maintain consistency while modifying the computation code. If needed, if you say less than 500, then 0.9 into 2 plus 0.1, else 0.9 into 5 plus 0.2, and else if you say less than 500, bill 0.95 into 2 plus 0.1, else 0.95 into 2 plus 5 plus 0.2. Can be written more clearly as if it had scale is equal to 0.9, real scale is equal to 0.95, and if you say less than 500, base is equal to 0.2, rate is equal to 0.1, else base is equal to pi, is equal to n, bill is equal to scale star base plus rate star usage. Try to simplify nested if contrast. Use of functions combined with conditions can reduce the need for nested if statement. Replace if x less than or equal to y, less than x less than or equal to z, smallest is equal to x, else smallest is y, and else if y less than or equal to z, smallest y, else smallest is z, and the end. Try to simplify the nested if x less than or equal to smallest min of x comma z, else smallest min of y comma z, and smallest min of x comma y comma z. Avoid the conditional expression if 0. This expression is sometimes used to temporarily bypass a block of code. Do not use it. Instead, use block comments and do not reduce code containing if 0. Include otherwise with switch statements. Leaving otherwise out is a common error, which can lead to unexpected results because none of the cases may be executed. Use a construct such as switch condition, case ABC, case F, otherwise end. Consider using a cell array to simplify a switch contrast. You can often use a cell array to consolidate the selections that can be handled with a single block of code. Replace switch over day, case Monday, day number 2, case Tuesday, day number 3, otherwise error bad day, end. Also using accelerate to simplify switch construct with the more flexible all days Monday, Tuesday, index string of DI, day all days, empty index, day number 2, main index, else error and give a day. Or all days, Mondays, Tuesdays, switch days. In case all days, index string copy I, days, all days, day number, find index, otherwise error and give a day. And unlike the first version, these later versions can be compared to generalized by all days, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Use if when the condition is most clearly written as an expression. The if constructor excludes statements when if or else if expression is true. These include explicit or implied logical or relational expressions. The if construct can be used for both inequality and equality. An example would be we code to determine the location of a number as above, inside or below the bounds of the interval with all numbers as variables. Use switch when the condition is most clearly written as a value. The switch construction only evaluates for equality. Use the switch construct in a single expression. The switch expression is compared with a series of case values. Its best use is in comparing characteristics or numerical values. When either if or switch can work, use the more readable one. There is a possible overlap in the usages of if and switch. Use the construct provides cleaner, easier to read code. Use logical to cast variables. Use the function logical to cast variables that will be used for logical indexing. Some computations or functions produce results that consists of only 1 or 0 values that could be used as indices. In some cases, MATLAB introverts a 0 that is intended to be logical as invalid numerical index. Use the logical function to avoid this problem. For example, A1, 2, semicolon 3, 4, A logical I2 returns answer 1, 4, but A I2 subscript indices must be either real, positive integers, or logicals. Use true or false functions and values. Use the true or false function to define the logical variable. Is valid, true, in rows and column. Is faster and easier to read than is valid, logical, once in rows in column. Similarly, use true or false values such as while true rather than while one for an intermediate while loop. In general, use is equal rather than equal to. The major advantage of each super function is that it works with a variable that have different sizes, which equal to does not. Both is equal and equal to work with variables that are the same size. The each equal function yields a single overall result of the comparison, which is usually the desired result. The equal to operator yields a result the same size as the variable. You could use all with equal to produce an overall result, but using is equal is simpler. In general, use equal rather than equal to replace 1 equal to 1 1 1, which produces an array with is equal 1 1 1 1 1. In general, replace 1 1 1 equal to 1 1 0, which produces 3 values with is equal 1 1 1 1 1 0, which produces 1 value. Be thoughtful with vectorization. Older versions of MATLAB has significant performance problems with code written in loops. Newer versions often provide equivalent or even better performance problems of vectorized code. This is especially true with computer variables are pre-allocated and just-in-time acceleration can be applied. Vectorization is also less capable about data variables because of memory limit issues. More MATLAB developers understand straightforward vectorization, but many of us bogged down at the more arcane example. Vectorization doesn't have a good home in linear algebra applications. Even in those cases, it can benefit from exploratory commands for non-specialists. Use repeat math. Use repeat math to replicate a subarray to construct a larger array. Unless the speed is a problem, the older technique A colon comma 1 once 1 is to n columns, or B A star once 1 comma n columns are effective and maybe faster than repeat math, but there are more difficult to read and less flexible than B repeat math A comma 1 n columns. Modularize, decompose major tasks into subtasks. The best way to take a big problem to assemble it from well-defined small pieces, usually functions. This approach enhances readability, understanding, and testing by reducing the amount of text that must be read to see what the code is doing. Small, well-defined functions are also more likely to be usable in an application. Small, focused functions are easier to test and modify than complicated ones. Code longer than two editor screens is a candidate for partitioning into functions or functions. Keeping related information together on the same editor screen lets you see certain types of problems and fix them right away. Displaying an entire logical unit on one screen also make it easier for the reader to mentally organize and understand the code. Write code as functions when possible. Functions modular computation by using internal variables that are part of the base workspace. They tend to be cleaner, more flexible, and better designed than scripts. The main role of scripts is in development because they provide direct visibility of variables, dimensions, types, and values. Write simple functions, write functions that do one thing and do it well. Try to write functions simple enough to describe more than two sentences. The goal is to achieve capability without complexity. Avoid multi-blade utility functions that require complicated interfaces. If the combination of multitasks is appropriate, then the individual task should be coded as helper functions or sub-functions. Design for loose coupling. Even every function should hide something. That is, it should perform a task that is not intertwined with other code. A function has loose coupling if it interacts with other code only through input and output arguments. Use well-defined interfaces is key to achieve reliable and understandable adaptable code. Tight coupling also leads to unit test problems. Modular test requires additional context. It also reduces extensibility and reusability. Furthermore, tight coupling allows error propagation and can lead to a chain of failures. Use subfunction appropriately. A function used by only one other function can be packaged as a subfunction in the same file. Keeping the code in one file can make it easier to understand and maintain. MATLAB allows subfunctions access from outside the main function file using a function handle. Access to subfunctions is a sign of undesirable tight coupling. If external access is required, then convert the subfunction functions unless a single file is required for portability. Aim for loose coupling between functions and the subfunctions. A subfunction should not have to change just because function input arguments change. The function input argument should not have to change if you change the subfunction implementation. Hide implementation details when possible. Design the function so that the internal implementation of each task can be changed without changing the interface argument. That way, changes to the function will not ripple out into other code. Write for cohesion. In a function with cohesion, most of the codes is related to one task or a small number of related tasks. Low cohesion leads to unnecessary complexity, loss of readability, and unlikely reusability. An example of low cohesion would be a function that computes many different statistical parameters from a data set, such as mean, median, mode, standard deviation, shape, parameters, quantities, max, min, and frequency. It's better to split this functionality among several things, with each computing only one or a few related parameters. Thank you.